It would be very helpful if you first try to solve the problem yourself before watching this video.
Question 206. Suppose f is the function given above. Find the values of a and b for which f is differentiable at x equal 2. Okay, for the function to be differentiable at x equal 2, first it has to be continuous at x equal 2, which means when x is equal to, this function value must be equal to this function value, right? So let's set up an equation. Ax plus 1 must be equal to 4x squared plus 3b at x equal to 2, right? So I'm going to substitute 2 for x. So 2 here, 2 here. So 2a plus 1 must be equal to 4 times 2 squared, 16 plus 3b. Let's say this is number 1 equation. Okay? And also, f must be differentiable, which means the derivative from left-hand side, derivative from this function, must be equal to the derivative from right-hand side, derivative of this function at x equal 2, right? So let's write left-hand derivative. F prime from left-hand side is equal to, what derivative of this is a, right? Derivative from right-hand side, since x is greater than 2 here, f prime x from right-hand side is equal to derivative of this, 8x, right? So these two must be equal to each other. A must be equal to 8x at x equal 2, right? So if x is 2, a is equal to 16. Okay, so substitute 16 for a right over here. Then we'll be able to find the value of b, right? So 2 times 16, let me do it right over here. 2 times 16, that's 32, plus 1 is equal to 16 plus 3b. So 33, 16 plus 3b, so 17 is equal to 3b. So what's b? b is 17 over 3, right? So a is 16 and b is 17 over 3.